Okay, so I think you're aware of a lot of this that I'll be discussing in this video, but we'll chat about it anyways. So, okay, so right now we've been pretty much chapters 1 through 4, right? So in 1 through 4, we've developed, actually technically 1 to 3, we've developed skills for displays, graphically and numerical tools for describing distributions. Okay, so here's kind of like the strategy that we've learned. Here's kind of the strategy that we have learned for exploring this quantitative data that we saw in chapter, I think quantitative was in chapter 3. Okay, so we always plot our data. Knowing what it's going to look like helps us a lot. Knowing the shape, the center, and the spread, striking outliers, departures, okay, calculating numerical summaries often help us, okay. And then sometimes there are overall patterns of large number of observations so regular that it can be described by a smooth curve. We'll eventually be calling this smooth curve our normal distribution, okay? And this is what most of chapter 5 is about. Okay, so for right now, we'll call it a density curve, although we're going to kind of eliminate that terminology very, very soon. So a density curve is a curve that it is always on or above the horizontal axis. Okay, it has exactly an area of 1 underneath the curve. Okay. A density curve describes the overall pattern of a distribution. The area under the curve and above any interval of values on the horizontal axis is the proportion of all observations that fall within that interval. Okay. So here's a histogram. It would be, it can be described by this quote unquote smooth curve, which we can also call a density curve for right now. Okay, so the overall pattern of this histogram, which is displaying their standardized test of some sort, can be described by a density curve. Okay, so underneath that curve you're talking about, there's an area of 1 there. Okay, so density curves, like distributions, they come in different shapes. Okay, so a density curve is often a good description of the overall pattern of a distribution. So they don't all have to necessarily look the same. It's just the overall pattern is similar. Okay, so outliers are described or not described by such a curve. Okay, so we're not talking about outliers here. Okay, it's very important too to realize that no set of real data is exactly described by a density curve. Okay, the density curve it's really just it's really just an approximation that is easy to use, and it's accurate enough for practical use. Okay, so it's not exact, but the approximation is good enough. Here's a funny little comic if you want to read it through real quick. And a lot of these ideas we already know, but we'll take a quick look at them. Okay, so the measures of center and spread, they will also apply to your density curves. Okay, and much of this we already know. So your median of your data is your halfway point. Often here we'll describe it as being an equal areas point. Okay, because it is the area under the curve, under half of the curve. Okay, so you have half left and half right. Okay, if it's symmetric, you know your center is where your median is. Okay, if your data is skewed, it's not as easy to see where it would be. It's easier to see kind of where it would be in terms of where you think your mean would be. Okay, but we'll get to that in a moment. The mean is more of your balance point. So because the mean will take into consideration everything, your highs, your lows, we could call it kind of balances out the rest of the data. Okay. Again, if it's symmetric, the mean would be in the center. Okay. It would not be as easy, but you can find a general location depending on if it was skewed or not. Okay. The median and the mean would be the same if they were symmetric. Okay, they would both lie at the center. Okay, the mean of a skewed curve would be pulled away from the median in the direction of the long tail. Okay, so these are kind of two that you can see. Not exactly perfect on B where you think the median would be, although it's easier if you knew where your mean is to put your median or vice versa. Okay, so this is it for this video, believe it or not. We will move on next time.